If the following pairs of atoms form bonds, how would you classify each of those bonds? And we're given some choices here. So one thing to note is that there's more than one way to describe the nature of a bond, and even the most ionic bond and the most covalent bond are still going to have some ionic character as well as some covalent character. So we have a couple scales from two different textbooks. This one here gives you a range. It doesn't have like strict cutoffs like this textbook does, where it says, if it's 1.1, it's very polar. But you'll have to consider, so there aren't these strict cutoffs, even though this textbook uses it. It's more of to build your awareness that that bonds do have certain amount of ionic and certain amount of covalent character. You'll have to consider the properties of that compound if it's unclear using one method or another. All right, so this here is the electronegativity values that were quantitatively developed by Linus Pauling, which is what we widely use. So electronegativity is the desire for, well, let's do this here, is the ability of an atom in a molecule, let's say this is a molecule, to attract shared electrons. So here are your shared electrons, so H is going to have some attraction for those shared electrons, and X is also going to have some attraction for those shared electrons. And if that electronegativity is the same, that would be its nonpolar. This molecule is nonpolar. Whereas if they're very different, the opposite extreme, then you would say these electrons are transferred from one to the other and then classify them as ionic. So let's take a look at number 1, or part A, nitrogen and hydrogen, and we're going to go with this table down here because that's where the textbook where the problem came from. Nitrogen has an electronegativity value of 3, hydrogen 2.1, so the difference is 0.9. So according to this textbook, you would classify as moderately polar. Now the bond is not the molecule, because we're not told what the molecule is. Next, fluorine and fluorine, we don't need any chart or table because when you have atoms from the same element, they're going to have the same electronegativity. So this is nonpolar. They're going to be shared equally between those two elements if they were bonded. Calcium and chlorine, and that's a classic metal, non-metal. That's stuff in rock salt. We use that commonly in our labs. Calcium, chlorine. So that is electronegativity of 2. So that's over here. So that's going to be ionic. And then finally, let's go with here. You might say aluminum, that's a metal. Chlorine, that's a nonmetal. That must be an ionic compound or an ionic bond. But if you take a look at aluminum, it's near the middle of the periodic table. So it's not going to have a great difference in electronegativity with any other element. So the difference between chlorine and aluminum is 1.5. So that's going to put it here into the very polar category. So again, if you have like aluminum chloride, so some of these are very obvious. There's not going to be much debate over whether calcium chloride or sodium chloride is ionic, but aluminum chloride, because by one definition you may have learned is a metal and a nonmetal, and according to this chart, it's covalent, right? So you'll have to consider its properties. You might look this up and see that it has a much lower melting point than other ionic compounds. You might have to consider its structure. Is it a crystal lattice structure? Does it conduct electricity when it's molten? So you have to consider various other descriptions of the compound when things don't line up clearly with one definition.